Okay, let's get started with the computed muscle control. So first we'll go to the Tools menu and select Computed Muscle Control. Um, so this first box, we will select our kinematics file that we just created using inverse kinematics. That has all the motion data stored within it. We'll next select Filter Kinematics. That will just make all of the values a little smoother. Next we'll go to select Tracking Tasks. So there should be a file included with your model. If it's one of the models that came with OpenSim that has the CMC task, we'll just go ahead and select that. That basically just tells it what to do. So then we will rename the file, whatever it is that we want. So I'm going to go ahead and name mine subject1, and then we select the directory where we would like to save that. So I'm going to create a new folder, call it subject1, and then open that, and that should make it so it saves in there. So let's go to the next pane, actuators and external loads. So we first need to add the actuator file. So that, once again, is another file that should be included with the model. So that's just called CMC actuators. So we'll select that, open it. And then we're going to go ahead and add the external loads so we can have the ground reaction force factored in. So to do that, we'll click on the little pencil there because we need to create a new file. So first, we need to select the file. So we need to select the MOT file that corresponds to this data. So let's go ahead and find that and plug that in. Then once again, hit Filter Kinematics, make it a little smoother, and then click Add. Then that'll bring up this box. So here you'll first name it. So we're going to name it ground because it is the ground force. Then here you can choose which body the force is going to be applied to. So with normal walking, it's going to be to the calcaneus, and it's the left foot in this case. So then choose Apply Force. You can choose between a point force and a body force. A point force will apply the force to the center of pressure. A body force will apply to the origin of the body. So then we gotta use these columns. The force column will be the magnitude, so that should be the one with the Vx. The point column is where the center of pressure is, and that should be the one with the Px. And you'll have to check the 1 and the 2, but it's just based on what force plate you use. Do the same thing with the torque. Select that and select the applied torque box, and then check, make sure everything's okay, looks good. So we'll click OK. So that our force is saved there. So now we just got to save the file. You can choose whatever name you want for it. Put it in the directory that you want, and then we'll go ahead and save it. So I'm just going to call mine force right now, and then we'll save it. So we should be good to go now. Let's double check and look at everything. Integrator settings, I don't really worry about that too much. It's mostly these other two boxes that are panes that are most important. So it looks like everything is good to go. We have all of the different parts of the setup, so we'll go ahead and click run. So now it should be going. You can see some things start to happening over there on the left. You can see the model. It will slowly move as it's making progress. Down in the lower right here, there's a little progress panel, and you can watch as it keeps going. So you can see bit by bit. It's kind of starting. The starting usually takes the longest. But anyways, that's the basics of computed muscle control. Okay, so a few more quick thoughts about using the CMC tool. First is filtering. And so you'll notice right here is the box that you can check to filter the kinematics, and it's automatically set at 6 Hertz. That is what we used in our study, and that is the default value, but depending on exactly what you're doing, you may want or need to change that. So it doesn't necessarily have to be 6 Hertz, and it can be changed from that in order to fit your own study needs. That is also the case here in the external loads. If you choose to filter it here, then it can also be changed to a different value. Along with it, if you don't check it, or if you check it and choose a negative value, it won't filter, and that's how you can do that as well. Also, when you're saving your external force, saving this file for the external force, there's no specific way that you need to name it or anything. when we saved it, we had a specific way of naming our trials, and so we were kept consistent with that. But that'll just depend on your individual study, um, and how you have decided to name things. But I tend to keep it in the same folder as the other files that I use there. So for example, like the force data file that we use and the TRC file that we use, I try to keep it in the same place as those, so all of them are grouped together. Um, Also, another quick comment: once you start CMC, while it's progressing, down here in the corner there'll be a little progress bar that'll say how close to being done it is. There's also a little red X that you can click that can stop the CMC tool. If you do this, well, naturally it will, and then select that you're sure you want to do that, it will stop CMC. It will not continue running. It's not the kind of thing where you can pause it and restart it later. It has to either run through until completion, or if you stop it, then you'll have to completely restart it again later on. No output files will be written if you do that. You have to start from the beginning, which, maybe you did maybe that's necessary, but there's no way to just pause it and then restart it later. Also, you may notice at times, there may be times when you're running the CMC tool that an error message may pop up saying that the model couldn't generate enough force or different things in order to complete the simulation. And it'll often give you some reasons of why, what went wrong, or some possibilities of what could have happened. But the bottom line is it couldn't finish running CMC. One of the main reasons that we came across that this often happened is that the model in and of itself wasn't strong enough to create the forces necessary. The first fix is to make sure that you have your additional set of actuators applied here, or added in, and I showed how to do that earlier. The other thing and if you've already done that and you're still having problems, it may be that the muscles themselves in the default model aren't as strong as they could be. I don't know if this is necessarily the best way to do it, but one way that we found to do it that works is to go in here to for the different aspects of the model, and you can gain access to the muscles and to their characteristics, their attributes. And so you click on here for forces, and then muscles, and then all. And then if you select, first you can select one of them. I'll just select one to show you what it's like. But there are all these different values for these different things, and for us, the default value for this one right here, the max control, was only set to 1, and increasing that number will often resolve that problem. It'll give the model enough strength to produce the force necessary to go through the simulation. So in ours, we ended up having to change it from 1 to 1,000. We did that for all of the muscles, and you can do that just by going down here and selecting all of them, and then going here to max control and entering 1,000 or whatever value it is you want to do, and then hitting enter or selecting away, and then you have to wait for it to enter that in for all of them. But then those muscles should be changed then to have that additional power, and that should allow your model to create the forces necessary in order to complete the simulation. So that's just another problem that we sometimes ran into. That's a possible solution. May not be the best way, but it's a way that worked for us. And so that's how you can solve at least that problem.